Boolean algebra. Let me check. Have I started the recording? Yes. So let me ask you, what is 1 plus 1? So you will be very eagerly answering, sir, that 1 plus 1 is 2. But this is in which format? So it is our decimal numeral. Yeah, decimal. Okay. Now 1 plus 1, if I ask you in binary, so you will say, sir, 1 plus 1 is 0, carry 1. Okay. So this you know, this is what? This is 2. Okay, in decimal, this is 2. 1 0 is 2. Now in Boolean, what is 1 plus 1? In Boolean algebra, 1 plus 1 corresponds to 1. Okay. So this is your what? This is your Boolean algebra. Okay, Boolean algebra. Now there are few rules that are related to Boolean algebra. So one by one we are going to see those rules. Okay. So law of Boolean algebra, give heading. So first, what is complement of 0? You will say that it is 1. Complement of 1, that is your 0. So what is 0 and 0 or 0 dot d 0? It will be 0. 0 1 0, so this will be also 0. 1 dot 0, so this will be also 0. 1 dot 1, this will be 1. Okay, this will be 1. Similarly, you can also write for 0 or 0. So 0 or 0 will be what? 0. This will be 1. This will be 1. And this will be also 1. So these are all the basic law of Boolean algebra. We should be knowing that if we or anytime if we or two inputs, and if one of the input is high, you can see high, this is high. So output will be always high. For making the output low, all the input should be low. Okay, so these are basic simple laws of Boolean algebra that I have written. Now the next law is what? It is your AND law. So what is this? A dot 0. Obviously this is going to be 0. Why? Because A can be anything. A, it doesn't matter even if it is 0 or 1. If we AND anything with 0, output will be always 0. Here you can see this is what? A dot 1. So obviously this will be A, because this will depend on the state of A. If A is equal to 0, then output will be 0. If A is equal to 1, then output will be 1. So we are dependent on the value of A. What is A dot A complement? A dot A complement, what it will be? Anyone want to say?
Sir, 0.
Yes, very good. It will be 0. Okay, so this will be 0. Why? Because if A is 0, A complement will be 1. And if A is 1, A complement will be 0. So if you assume value of A as 0, A complement is 1. So that is 0 dot 1. So this will be obviously what? This will be 0 always. And what is A dot A? It is very simple. It will be A. Now similarly, we have what? We have our OR law. Okay, OR law. So A or 0, this will be what? This will be A. What is A plus 1? A plus 1? A or 1?
1, sir,
Yes,
1.
obviously this will be 1. Why? Because even if A is 0 or A is 1, it doesn't matter. if one of the input is 1, okay, so output will be always high or it will be always 1. Now a complement, a plus a complement, so this will be what? This will be also 1. Okay, this will be 1. And here it will be what? It will be a. Okay, a plus a, this will be a. Very simple. Okay, any doubts up to this point? Anyone? Any
Yes,
doubt?
sir. Yes, sir.
Okay, fine.
So the fourth point, there must be also the points like 0 plus 0, 1 plus 0 also will come, no, sir?
What? 1 plus 0?
So just do one, just do one, sir, like fourth one. I'm getting the
This one.
cases like 0. Yeah, sir. It will be cases will be like, sir, 0 plus 0. No, 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 sir, it's fine. Okay, sir,
0
go
plus
ahead.
0. Yeah, a
And one,
can be anything. So,
yeah.
see, I am not even writing all these cases. You can have 4 more cases. You can write like a complement plus 0, a complement plus 1. Okay, this it won't be affecting because if I write a complement plus a, it is the same thing. Or over you can write a complement plus a complement. So you can have 4 more cases over here with the complements also. So this will be what? A complement. This will be, sorry, 1, this will be 1, this will be a complement. So these are, means I am not writing any more these things. Okay, so okay, now let us move to not law. So according to not law, this is very simple. Okay, so if a is means there can be what? First, if a is equal to 0, a complement will be equal to 1. Okay, if a is equal to 1, a complement will be equal to 0. Third, if I take double complement, obviously this will be equal to ay, because complement it will cancel out each other, like 0 complement again complement, this will be equal to 0. Why? Because 0 complement, this is 1. If I take once more complement on this, so this will be what? 1 complement, so that is 0. You can see this is again returning back. So this is what? This is your simple not law. Now next is what? Commutative law. Okay, commutative. What do you mean by commutative law? What do you mean by commutative law?
If we interchange the values, like the places of the value, then this doesn't affect the result.
If we interchange the inputs, output doesn't get affected. Okay, so this is what? This is your commutative law. Like A plus B, this is equal to what? B plus A. Okay, simple. If you do OR gate, if you take OR gate, so if this is A, this is B, this will be A plus B. So this is equivalent to, so this is the same thing. Okay. Second, it can be A dot B, it is equal to B dot A. Third can be what? A dot B, this is equal to B dot A whole complement. Okay. A XOR B, this is equal to B XOR A. And sixth point is what? A XNOR B is equal to B XNOR A. So here you can see all the gates, okay, all the gates, whether it be OR, AND, NOR, NAND, XOR, XNOR, all the gates follow commutative law. Okay, all the gates, they follow what? They follow the commutative law. Okay. Now next is what? Associative law. So what do you mean by associative law? Can anyone tell me what is associative law? What is associative?
Sir, can you please go to the previous slide for 1 second? Thank
Yeah.
you.
So what do we mean by associative law? Anyone want to say what is associative law? Till the time your friend copies.
So it's like if we perform an operation into A
Hmm.
plus B and perform then same operation with C, it will be equal to if we perform the same operation between B and C and then perform the same operation with A.
Okay, fine. So in language, what we should write? If we interchange the order of operation, then output, if it does not change, then it is associative. Like what? A plus B plus C. If I put bracket over here, this is equal to A plus B plus C. Okay. So this means what? This is equivalent to, okay. So this is what we mean by associative law. Now can you tell me which all gates are associative and which all gates are not associative? Can you think about it? So which all gates are associative?
So not gate.
No, not gate. You don't have like you just have a single input. Okay, you just have a single input. So in not gate, it is even not following your commutative law because you
Let's
just have a single
let's solve
input.
gate.
How XOR gate will not be associative? So do you think this will not be associative? Tell me. So 1 XOR 1 XOR 0. So if I perform it like this, so this will be what? This will be 0 XOR 0. So obviously this is 0. Now if I change the order, something like this. So this is what? 1 XOR 0. So this will be 1. So 1 XOR 1 again 0. You are getting the same thing. Even with XNOR gate, AND gate is associative. Yes, AND gate is associative. So this is AND gate, this is OR gate, this is XOR gate. This now I will be writing XNOR gate. Even this is what? This is your associative. You can see all the gates are associative. What about NOR gate and XNOR gate? What about, very sorry. What about NAND gate and NOR gate? Is it associative? NAND gate and NOR gate, are they associative? Think about it. So look very carefully. Are they the same thing? Is this a same means, will this equation hold true? Tell me yes or no. Or even this one. See, I have changed the order. Okay, I have changed the order. That's it. Tell me, will this be same? Will this equation hold? This
No,
will
sir.
not hold. This will not hold. You can check this using truth table if you want. Okay, I am not doing. So NAND and NOR, they are basically not associative. Okay, they are not associative. So you should be writing universal gate, note point, universal gate is not associative. So today's class you might feel a little bit bored because all we have is theory. Okay, in this part we have only theory. So in the next class I will bring questions. Okay, I will bring questions. So today's class is little bit about everything about this Boolean algebra. So it's kind of theoretical. Okay, but we need it actually. So now next is what? Distributive property. What is distributive property we have? So can anyone tell me what will be this? This is very simple. This will be AB plus BC. What about this one? What about this one? So this will be, pardon, I couldn't hear you. So this two, who has unmuted? My voice is echoing. So kindly mute yourself, okay? So if you are logged in using two devices, this thing happens. So one of the devices should be muted always, okay? Or your voice, it will be echoing. Yeah. So you can see this is a very, very important property that A plus B is equal to, sorry, A plus BC, it is equal to A plus B and A plus C. Now you might be thinking how? So let us prove it. A plus B into A plus C. So let us open the bracket. So this will be what? A dot A plus A dot C plus B dot A plus B dot C. Okay. So from this 3, I can take A common. So A common. So this will be what? A dot A is what? A dot A will be A only. So this will be 1 plus C plus B plus BC. Now I have already told you 1 plus x in Boolean, it is what? It is equal to 1. Okay. In Boolean law, I have told you. So I can simply write it as A plus BC. So you can see what? This is again equal to left hand side. So RHS is equal to LHS. So that is why this is the theorem. And this is what? This is just the opposite. Okay. A plus B into, means into, I am telling, and A plus C, this is equal to A plus BC. Did we understand this or not? Distributive property. The next is what? Absorption law. What is happening? Okay. So even if you don't remember the name that this is distributive law or this is absorption law, it is okay. Okay. It's fine. It's totally fine. So this will be what? This will be A common if you take. You take A common. So this will be 1 plus B or this is A. What about this one? This will be A dot A plus AB. So again you will be getting A plus AB. So this will be what? If you take A common, so this will be 1 plus B or you are getting A once again. So even if you don't remember the names, it's okay. You just need to see that what result you will get. Okay, sometimes during expansion or what you can say, that thing, minimizing the expression, okay, minimizing the expression, you require all these laws. But even if you don't remember, you will be able to minimize it with the help of K-map. So K-map mostly, I think it will be done in the next class. Okay, today we are just going to deal with Boolean law. Okay, so any doubt up to this point, let me know. Any doubts, anyone? Any doubts? Any doubt, anyone?
No, sir.
Okay, fine. So now let me ask you one thing. So De Morgan's theorem we have already discussed. Okay, De Morgan's theorem. So before going to De Morgan's theorem, I remembered one thing. Any one of you, have you heard about this one? Consensus law? Okay, you haven't heard. So can you minimize this expression and tell me what this will be? So minimize this one. So next, what example shall I keep? A, B. Yeah. So did we minimize? See this expression, okay, A dot B plus B bar C plus AC, I can write it like this. Can I write it like this? See, so there is what means AB plus B bar C dot 1 plus AC. So this one I have written it like this, A plus A bar. Okay, I have substituted 1 as A plus A bar and I have written this over here. So now what am I going to do? Look very carefully. A B bar C plus A bar B bar C plus A C. Okay. So now what can I do? I can club this two and I can club this two. So look what will happen. Okay, I cannot club this two. Oh, wait. I need to club something different. So A, so here B bar C. Okay, I can club this two. Okay, let us club any one of the following. It's okay. Eventually we will get the answer. So just a minute. This two we can club. So we will be getting no, it will not be helpful. So this two let me club. So what will happen? This will become AB plus A bar B bar C plus this will be what? If I take AC common, so this will be 1 plus B bar. Okay, 1 plus B bar, yes. So this will be what? AB plus A bar B bar C plus AC. Okay, so now what can I do? So I should have told this after K-map. So with K-map this is very simple. So what I can do over here? Okay, so A bar C, if I take common, no, that will not be helpful. So somewhere have I made some mistake or what? Means in the manipulation part I am thinking. Okay, so let me try it once again. So this I can write it as AB plus AC plus B bar C. And what can I write over here? Let me write it as, oh, I'm stuck little bit over here. Okay. Okay. So which part I am thinking to open? Okay. A bar, B bar, C. So that will be okay. Fine. So B bar. So this part. Okay. Let me expand this one. Maybe I was doing some mistake. So see here very carefully. AB plus B bar C plus this one. Okay. What? Please take AB, A bar, C together. Yes, we will do. Look over here. So this one I can write it like this. B plus B bar into C. Okay. So this is what AB plus B bar C plus ABC plus A B bar C. Hopefully this time we will be able to do. So yes, now it is okay. So this two and this two. Okay, so look, this will be what? AB common. So from here 1 plus C, and if I take this 2, so this will be what? Plus B bar C 1 plus A. So this comes out to be what? AB plus B bar C. So this is what? AB plus B bar C. Okay. Is this clear? Tell me. Now I will tell you one trick. First tell me what will be the reduced expression for this second one. Quickly tell me. Tell me. Then I will tell you how to actually see, means what is the shortcut. Okay. First you tell me what will be this one. See, if you solve this also using the same methodology, so what I am going to do, I am going to expand this one. Okay. So this is what? A bar B plus A plus A bar BC plus AC. So if I expand this, so this will be A bar B plus ABC plus A bar BC plus AC. Okay. So what shall I take common? This one and this one. So if I take, so this will be A bar B is common, 1 plus C, and from here it will be what? AC common, 1 plus B. Okay. So this is what? A bar B plus AC. Now let me share the trick with you. Look over here. A, B, C. Okay. Now basically, look very carefully. The terms present over here, A, B, B, C, A, C. So A, B, B, C, A, C. So these are all cyclic terms. Okay. If it is 3 variable, you can see this will be A, B, B, C, A, C. Along with that, you can see out of A, B, C, only one of the variable has a normal term and a complemented term. Over here, it is what? This B. You can see this B has complement and this B has non-complemented form. So when you apply consensus law, you are going to retain only those terms which has one non-complemented and one complemented. Okay. So here you can see B has only complemented and non-complemented. So you are going to retain all those variables, means all those min terms. These are known as min terms. Okay, min terms. But later on we are going to study what is min terms. So you are going to retain only those expressions, only those min terms where you have a complemented and non-complemented variable. So here you can see A, B and B, C. Next, come over here. you have complemented in A and non-complemented in A. So obviously you are going to retain this two. So look over here, I have retained this two. Now tell me from this third example, 1, 2 and 3, which terms are you going to retain? Look for the complemented and uncomplemented terms. Which terms are you going to retain? 1, 2 and 3. What happened? 1 and 3 should be retained. Very good. So here you can see A has normal form as well as complemented form, whereas B is existing only in complemented form, as well as C, it is only existing in complemented form. So you have to retain the min terms of A only. So min terms of A means what? This one and this one. So this will be what? AB bar plus A bar C bar. Okay, is this clear? Tell me, is this clear? Clear to everyone? Okay, last example. Now tell me. Now tell me.
So second and third term.
Okay, just a minute. Give me a minute. Yeah. So second and third term. Why? You are telling second and third term? Yeah, second and third term. Why? If you look at A is present only in non-complemented form. B is present in non-complemented, whereas C is present in both non-complemented as well as complemented. So we are going to retain the min terms of C. So that will be BC plus C complement A. Okay, one more example. Now tell me. Tell me very quickly. 1 and 3 should be retained. Very good. So this is written in, means this was min term. These are max terms. We are going to see sum of product, product of sum. Okay. So usually I told you, I tell this after K map. Okay. But it's okay. We can discuss this over here also. So you can see here we have A, B, C again in cyclic fashion. So A, it is present in both complemented as well as non-complemented form. B is present only in complemented form, sorry, non-complemented, and C is also present in non-complemented form. So retain terms of A. So these two are going to be retained. So A plus B and C plus A bar. Okay. Now last one. Okay, last. Now tell me.
Second and third.
Yes, very good. Second and third, because C is present in normal as well as complemented. So this will be B complement plus C, C complement plus A. Okay, so this is very simple yet very useful. Once they have asked directly this consensus law in GATE examination, so they have given this kind of expression. Okay, max term they have given, or sum of, sorry, product of sum. This is known as product of sums. So they have given this and they asked what will be the minimized expression. So you need to know this consensus law. Okay. Now the next is what? De Morgan's theorem. So De Morgan's theorem, we have already seen what? A plus B whole complement, this is equal to what? A complement dot B complement. Or if I want to write AB whole complement, this is equal to what? A complement plus B complement. This even holds in your more than two inputs, means A plus B plus C whole complement. This will be equal to A complement, B complement, C complement, and A, B, C whole complement. This is equal to A complement plus B complement plus C complement. So this is what? This is your De Morgan's theorem. So I won't be means making a proof, means proofing this for you. Okay, this is very simple, and we have already done this when we were discussing NAND gate and NOR gate. Okay, so now next is what? We need to find dual of a function. So what is dual of a function? Can anyone tell me? What is dual of Boolean function? Can you tell? What is dual of a Boolean function? So dual means what? If you have a Boolean function, okay, let me denote it by f. If you have a Boolean function, okay, so simply the dual you will get, so dual I am denoting by f of d, okay, fd. So you will get by interchanging the ones to 0 and 0 to 1, so 1 to 0 and 0 to 1, and interchanging the plus means or with and, or interchanging the and with or. Okay, so basically it is interchanging of 1 to 0 or 0 to 1, or interchanging of plus to dot and vice versa. For example, let us take one example. So let f is equal to a b c plus d e. So how do we calculate the dual? So look very carefully. So I should have written it like this. So dual function, what I told, you need to replace the dot with plus and vice versa, and 1 with 0 vice versa. So here you can see all the places we have what is dot, here also dot, and here we have 1 plus. So what I am going to do, look very carefully. This dot I am replacing with plus, this one with also plus, and this plus will be replaced with a dot. Okay, so this is what? This is dual of this function. Tell me, is this clear? Now let me ask you one more. Tell me what will be dual of the function. You write it in your notebook. See, making proper notes is an art, okay? So you should be doing that very properly. If you don't know how to make your notes properly, then you won't be able to revise also, okay? You won't be able to revise as well. So revision means, for proper revision you need to make proper notes also, because you will be revising after like 2 to 3 months. Okay, you might be revising. So at that time, if you don't understand what you yourself have written, so how are you going to revise? So your note should be very proper and to the point. So if you calculate the dual over here, so you can see over this place there is plus, so I will replace it with dot, and here it is plus, and over here this is plus d. So obviously I need to put a bracket over here, okay, because this is what? This term x means this term or d. So over here, I will be putting a bracket and then I am going to write D. How many of you got this? Tell me. A plus B. What is this? Why did you get plus C over here?
So that was a misprint.
Yeah,
Actually, I had the
yeah,
same
you
answer.
can. Yes, you have the same answer. If you use the distributive that which property I said, this absorption law, you can again
Okay.
write it in that way. Yeah, so that is okay. Okay, fine. Now one thing to note over here, note point, don't complement any term. Okay, don't complement any term like putting a bar over here or over here. Don't do all those things. Okay, we are going to see when we are going to do that. Okay, okay, fine. Now, principle of duality. What do we mean by principle of duality is that if we have a valid Boolean function, then the dual that we get, it will be also valid. For example, if you see, few minutes ago, we read this absorption law. Okay, so let me write it as capital F. So this is my function. Okay, so if I take dual of this, so what it will be? So you can see this will be A plus BC. Okay, A plus BC. And what we know, basically, this is what? This is what? This is your valid function. Okay, this is your valid Boolean expression. Or even if I ask you to write for this, see, look, A plus 0. If this is F, so if you write dual function, so next will be what? A plus will be replaced with what? It will be replaced with your dot, and this will be what? 0 will be replaced by 1. So you can see this is also a valid dual function. Okay, this is also valid dual function. Are we getting this or not? Tell me. See, means I should have explained it more better. Uh, okay, fine. So first take this example. Yeah, it's okay. I will erase it once again. So if I take, means if I solve this, okay, so this will be what? It's what I taken. Just a minute. Yeah, this expression was there. So look very carefully. Okay, this expression I have. So this is what? AB plus BC. Okay. Now take dual. If you take dual of the above function, so this will be what? A plus B dot C. Now if you expand this, this is what? A plus B, A plus C. Okay. So what will you get over here? A plus AC plus AB plus BC. So this is again coming back to what? This is coming back to A plus BC. Okay, A plus BC. Tell me if this is clear to you or not. See if this is clear or not. Tell me if this is okay.
Yes,
Is
sir.
this clear? See, over here also if you take dual, okay, over here also in this expression you can take dual. So this will be what? A plus B, and this is what? Dot B plus C. Somewhere have I made some mistake or what? Why are we not getting the same thing over here? Some place I have made some mistake. A B A C. This should have been AC, na? Why have I written C? Look over here. You people didn't even correct. This is AB dot AC. So that is why I'm thinking, why is this happening? So what clear? You guys should have told me, sir, you have written mistake. So this is AB plus AC. Okay. So now you can see, if I take dual of this, so this will be what? A plus B dot A plus C. And even over here, we know what? You can see I have got the same expression from the dual also. Look over here. So you are getting the same expression from F as well as from dual. One more example, let me show you of this one. Okay. So you might have got confused in the previous example. So look, A plus 0. What is this? This is A. Now if you solve for dual, so f of dual is what? So simply you are going to replace plus with dot and 0 with 1. So this will be A dot 1. So what is A dot 1? It is again A. So you can see f is equal to always f dual. It is just a different way of representation. Okay, a different way of representation. But whatever you get after solving, it is the same. Are you able to understand now? What is this principle of duality? Did we understand this? Last example. Third. So let me take f is equal to a dot 0. Okay, a dot 0. So if I take a dot 0, so this is means what? This is equal to 0. Now if you take f dual, so this will be what? A dot will be replaced with plus and 0 will be replaced with 1. So this is what? This is 1 plus a. Why am I getting again 1? What is happening? I should have got 0 over here. Why am I not getting? Why am I getting 1? What is happening? A dot 0. So this was 0 actually. So a plus 1. So why am I getting 1 over here? I should have got over here, if this is 1, so this should have also have been 1. This is just a different way of representation. That's it. Okay, just a minute. A plus 1. So this will be what? A dot 0. So this is 0. This is 1. So here your duality is failing, principle of duality. Now why it is failing? Wait a second. So 1 plus a is a valid expression. If we have a ball valid, so what invalid? Something, I guess there is invalid over here that I am overlooking. Okay, leave this example at the moment. There is some issue over here that I am not able to get. Okay, a equal to 1. So a yes. So usually we don't do what? We don't revise such kind of concepts, so we forget. Look over here. So I might have confused you a little bit. So look, that is what I was thinking. So f is equal to what? A plus 1. So this is equal to what? This is equal to 1. Okay, so this is this whole expression. This is f. Okay, this is f. Now what will be f dual? So f dual, this will be what? A plus will be replaced with a dot and 1 will be replaced with a 0, and over here this one is also going to be replaced with 0. So here you could see in this expression LHS equal to RHS, over here also LHS equal to RHS. So obviously whenever you have this is known as principle of duality, that whenever you have one valid Boolean expression, so I wasn't taking this into account, okay, when I was solving. So this is the valid Boolean expression, okay. Whenever you have a valid Boolean expression, so the dual for that also it is valid. Now is it clear? Tell me. If you have any doubts, please tell me. Any doubts, anyone? Quickly tell me if you have any doubt. Piyush, you can unmute yourself and type. Next is what? Next is, Piyush, you wanted to say something? Next is what? Next is complement. Okay, complement. How to find complement of a Boolean function using dual. Okay, so look very carefully. Suppose if I have a function like this, okay, I want to find f complement. So what I can do? I can take a XOR b whole complement. So this will be what? We know that this will be a XOR b, or this will be ab plus a complement b complement. Okay, we know this. Now suppose I want to calculate using dual. So f is what? A XOR b, or this is what? A dot b bar plus a complement b. Look very carefully. Okay, look very carefully. Now first calculate dual. First step is calculating dual. So if you calculate dual of this, so this will be what? A dot will be replaced with a plus b complement, and plus will be replaced with a dot. Okay. First step is for calculating the complement of a function. First step is calculating dual. Second step is what? Complement each term. Okay, complement what? Complement each term. So if you complement each term, what will happen? So this will be a complement plus b complement b complement, a complement plus b complement. So this will be what? This is going to be a complement plus b, a plus b complement. Now solve this. If you solve this, what will you get? You will be getting a complement into a plus a complement b complement plus ab plus b complement into b. So this will be 0, and over here we will be getting ab plus a b complement. So this is what? This is a XOR b. So you can see that this is the method of calculating complement of a Boolean expression using the dual method. Okay, did we understand this? Tell me. Any doubts? If you guys have no doubts, I want you to calculate the complement of this function. Okay, calculate the complement of this function. So this is kind of a little bit tricky. So find it very quickly. I'm giving you 1 minute to find. Did we get the answer? Yes or no? See, you should be very frank. If you are not understanding, let me know. That sir, we are not understanding some concept. If you are understanding, then you should be able to solve problem. So look very carefully. This is the question. So what is the first step? First step is calculating the dual. So if I calculate dual, look very carefully. So this will be what? A plus will be replaced with a dot. This is B complement dot C. So this will be B complement plus C. Next you can see what? There is a dot D over here. So this will be plus D. Okay, D complement. Next you have plus over here. So that will be dot whole means whole bracket E. Sorry, I have written E complement. So that will be E. Over here you can again see that this is dot. So plus F complement. And again there is what? There is plus. So obviously this is going to be, means I should be writing it like this. Bracket dot G. Okay, so I have dual. Now next step is what? I want to calculate the complement. So complement each term. So F complement will be what? It will be A complement dot B plus C complement plus double means D complement complement. So that will be D E complement plus F whole means whole G complement. So this will be the complement of this function. Tell me, are you getting this answer? Yes or no? Anyone got this answer? What about others? So today how many of you are present in the class? I haven't checked. So 4 guys are present. So did we get this or not?
Yes, sir, I get this.
Okay, you got this. Fine, very good. Okay, so this is about complement. Now let me ask you a question, that if suppose I have A1, A2 like this, an variable, okay, with this variables, how many unique functions can I construct? Okay, like if you have AB, so with the help of AB variable, how many functions can you generate? Like one function can be randomly, I am writing, one can be A, one can be B, another can be A plus B. Similarly, you can write AB. One more can be A complement plus B. Another can be A plus B complement, A complement B complement, A B complement. Such means like this. How many functions can you make using AB? First, you tell me this. Next, we are going to generalize it in n variable. So can you tell me how many functions can we generate using two variables? Anyone? See, it is very simple. Okay, only thing is that you should be knowing NC2. So NC2, that is very wrong, because what is 2C2? What is 2C2? What is 2C2? It is wrong, obviously. One. So already I have generated like 1, 2, 3, 4, 5, 6, 7, 8. 8 functions are there and you are getting 1. So that is quite wrong. So look very carefully. This question was asked in GATE. Okay. This is a GATE question. 2004 or 8. I am not sure, 4 or 8. So look very carefully. First look, how many functions can I generate using one variable? Okay, one variable. So A is one single variable. So your function 1 can be what? It can be A. Function 2 can be what? It can be A complement. Third function can be what? It can be A plus A complement. Fourth function can be what? It can be A dot A complement. So in total, can I make any other function using this variable A? Look very carefully. Can I make it? Look very carefully. I cannot make. So this will be what? This will be, sorry, this will be 1 and this will be 0. Now look very carefully. This is haphazard way of representation. If I want to represent this using tabular form, look how am I going to do it. So first write A. Okay, A. So A can take what kind of variables? It can be either A, simple A, or it can be in complemented form. Now this function, okay, function, let me represent it by alpha A plus beta A complement. Okay, I can write it for different values of alpha and beta. I can do what? I can generate different combinations. So let me write, where should I write alpha and beta? Okay, see very carefully. Now what can be the possible values of alpha and beta? Can you tell me? What can be the possible values of alpha and beta? One zero, obviously. So either both alpha beta will be 0 0, or alpha will be 0, beta will be 1, or alpha will be 1, beta will be 0, or both of them are 1. Now if you solve, so this is what? This is 0. Whenever you have alpha 0, beta 1, so this will be what? This will be A complement. Next is what? This will be A. And last one is what? Both of them is 1 and 1. So that will be A complement plus A. So that is what? That is 1. Okay, that will be 1. So you can see I got all the 4 variables, sorry, all the 4 functions that we were getting using this haphazard method. Okay, so this is the tabular representation. Now, means here for one variable, let me write over here. For one variable, I have 4 function. I cannot still generalize this. Okay, I cannot generalize it. Now, let us calculate for 2 variables. Okay, 2 variables. So 2 variables, it will be A and B. Can you tell me now? Can you make this table? So first calculate what can be the possible combinations of A and B. What can be the possible combinations of A and B? So look very carefully, I will only do. So AB can take values either A complement, B complement, or A B complement, sorry, A complement B, or A B complement, or AB. Means simply what I am doing means this will be 0 0, 0 1, 1 0, or 1 1. Okay, simply I am just encoding this, that 0 corresponds to complement and 1 corresponds to non-complement. Simply I am doing that. Okay. So over here, this term will correspond to what? This term will correspond to A complement, B complement, this will be A complement B, this will be AB complement, and this will be AB. Now I can write the generalized function as alpha A complement B complement plus beta A complement B plus gamma A, what is that? A B, and delta, okay, delta A B. I can write it like this. Okay, I can write it like this. So what can be the possible values of alpha, beta, gamma, delta? What can be the possible values of alpha, beta, gamma, delta? What happened? Array, these are all in binary. So alpha and beta, gamma, delta, they can only take values what? They can take values 0 or 1. Okay, 0 or 1. So alpha is corresponding to this expression, beta with this, gamma with this one, and this is delta. So now, how many combinations can I write? How many combinations can I write? How many combinations of alpha, beta, gamma, delta will be present? 16. Very good. It will be 16. So how will it be? It will be 0, 0. Quickly fill this table. Okay. So now, if you solve in this case, so here you can see all the alpha, beta, gamma, delta, they are 0. So obviously this is function 1. Function 1 corresponds, means I should have written over here, this is function 1, function 2, function 3, function 4, 5, function 6, function 7, function 8, function 9, function 10, function 11, 12, 13, 14, 15 and 16. You will be getting 16 functions. So this will be 0. Over here it will be AB. Over here this will be A complement B. Over here this will be what? This will be A common. So I can write B complement plus, sorry, this is what? This will be A. This will be A complement. See, I am just putting the values of alpha, beta over in this expression. That's it. So this will be what? Means in this expression, this will be alpha, beta. Over here, these two terms will be present. So this will be B. This is what? This is your A XOR B. A XOR B. Over here, I have three terms. So this will be A complement. So this will be A plus B. See, I am very quickly solving in my mind because I can do it. If you solve, you will also get the same. Are you understanding the concept? What is happening over here? Are you understanding? So this is what? This is your A dot B complement. So either this A complement dot B complement, look, either it will be this function. We know this is also equal to A B whole complement, A plus B whole complement. So I am taking care of all the functions that are present, whether in this min term format or max term format using this term. So how many total functions we got for two variable? For two variable we got 16. Now can you generalize this? Can you generalize? I am not solving all this. You can solve it yourself. These are very simple.
4 to the power n.
4 to the power n you are saying. No, it will not be 4 to the power n. Like for, okay, let me ask you, last for 3 variable. Okay, 3 variable. You said what? 4 to the power n. So according to you, this should be 4 cube. That is what? 64. But look over here, if you have 3 variables, so that will be A, B, C. Okay, A, B, C. So here, how many combinations will you have? You will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, triple 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. That means you will, means this corresponds to A complement dot B complement dot C complement. This will correspond to A complement dot B complement dot C. So like this you will have functions. Okay, so this will be a complement, b complement, c, this will be a, this will be a, b, like this you will have. Okay, you will have 8 different minterms. Now corresponding to this 8 different minterms you will have alpha, beta, delta, gamma, sorry, alpha, beta, delta, sorry, I had written the wrong way. So this is delta, means over here gamma. Okay, so like this you will have 8 coefficients. Now this 8 coefficients, it will have 2 to the power 8. So what is 2 to the power 8? So you will have over here 8 coefficients. So 8 coefficients, it will have what? It will have 2 to the power 8 combination. So 2 to the power 8 is what? What is 2 to the power 8? Yes, very good, Piyush. So that is 2 to the power n is the correct way. So this is 256, but you gave me answer 64. So this is wrong. So the generalized, if you have n variables, for n variables, the number of function is what? 2 to the power 2 to the power n. Now if you put 1, so this is what? 2 to the power 1. So that is 4 over here in this case. In the next case, you can see what? 2 square, 2 square. So this is 4, 16. If you put over here 2, 2 cube, so that is 2 to the power 8. So that is 256. So generalized is what? It is 2 to the power 2 to the power n for n variables. Tell me if this is clear or not. Did you understand this? So like this, means this was a very good question. Few of the students might have solved, because all the students, they were actually doing guesswork, and guesswork, it doesn't work. So this was actually what? This was your MCQ question. So you could have also put the values and you can have calculated, but it's okay. I have already shared the method with you. Is this clear? Tell me. Any doubts in this? Any doubts, anyone? Kindly respond. If any doubts, let me know. So the next is what? We have NAND circuit. Okay, what is this NAND circuit? So look very carefully. NAND circuit is, we have already seen the Boolean expression for this one. So I told you today's session will be little bit theory. Okay. So we have already seen such kind of expression. So NAND circuit means what? In the first stage, we have two NAND. So this is first stage. And in the second stage, we have a single NAND. Okay. So this is what? This is your NAND circuit. Basically, we are doing what? We are doing AND OR. We are implementing AND and OR. You can see A and B, C and V, and combinedly we are ORing the two. So it can be also represented like this. So the same thing we will be getting AB plus CD. So this is what? This is your AND OR circuit. Okay, AND OR circuit. This is very, very useful, because I have already shown you that how we implement few things. Okay, I have already shown you. Tell me, is this clear? Now the next, you might have guessed very properly that it is NOR circuit. Okay, NOR circuit. So in NOR circuit, basically in the first stage we have two NOR. So I will be again discussing all these circuits when I teach you SOP and POS, sum of product and product of sum. So this will be what? A nor B whole. Okay. So this will be what? A plus B using De Morgan's rule. C plus D. So you can see what? This is your NOR circuit. Tell me if this is clear or not. Is this clear? So we can implement the same circuit using what? We can implement it using OR AND. So sorry. Any doubts in this? Tell me. Any doubt? Any doubt? Tell me yes or no. Any problems up to this point? Okay, fine. So now, one thing I might have forgot. Yes, I forgot. See, we had actually discussed what? We had discussed how to construct basic gate and or not using NOR and NAND. But using this two gate, we never discuss how to construct XOR or XNOR. So okay, let us then do very quickly. First, construct using NAND. First you people try, then I will do. How many NAND gate are required for constructing XOR? Tell me. How many XOR gate are required for use means XOR gate, sorry, NAND gate are required for constructing this XOR and for XNOR?
Four.
4. Okay, very good. Very good. 4, it will be 4. So look very carefully how will be the structure. See, you might be very tempted to draw like this. So I am drawing a rough diagram. So what is XOR? It is A XOR B, A B XOR. So this is in our form only. Okay, we have seen how to construct AB plus CD. So it is kind of that only. So I can construct, if I am able to construct A complement. So this is A, this will be A complement. Okay, this is A complement. This is B, and over here, if I take so this is B, this is B complement, and over here this is A. So one more if I use, so this will be what? From here this is A dot B whole complement, and this will be A dot B complement whole complement. So this will be what? Whole complement dot A B complement whole complement whole complement. So you will be writing something like this: A complement B plus A B complement, and you will say, sir, for constructing NAND gate for constructing XOR gate using NAND, we require 5 NAND gate. Okay, you might be telling like this, but actually this function has a special kind of symmetry. So I will be erasing this. Look very carefully. If you have copied this down, if you haven't copied, so kindly copy this. Copy this. I will be erasing this. Okay, or else I will draw it in the next page. It's okay. You can later on copy when I send you the slides. So look very carefully. Here I have some symmetry, certain kind of symmetry. Now calculate what will be this. Calculate. So obviously this is coming to be A XOR B. Okay. Wow. So this will be your over here AB whole complement. This will be what? A dot AB whole complement. This will be B dot AB whole complement, and this will be what? A dot AB dot B dot AB whole complement. So this will come out to be A dot AB whole complement plus B dot AB whole complement. So this will be what? This will be A B bar plus B A bar. So that is what is your XOR. Okay, this is XOR. Okay, now if I want to, means here you can see 1 2 3 4 4 gates are required. Okay, 4 NAND gates are required for calculating, means for getting XOR. Now if I simply want XNOR, so we know what? Okay, so simply for constructing this NOT, we require one more NAND gate. So simple. If you want to construct XNOR gate, so simply do what? After this stage, add one inverter, and we know what? For adding inverter, we require one NAND gate. So this is what? This is your A XNOR B. So for this we require 5. Similarly, if you want to construct XNOR using NOR, so you are going to require 4 gates. How? Okay, I want you to calculate the output yourself. This time I am not going to help you. So this will be A XNOR B, and we know what? For XOR we require one more, and means one more NOT. So NOT can be constructed using one NOR gate. So if I simply add one more inverter over here, so we will be getting A XOR B. Tell me if this is clear or not. Is this clear? Any doubts in this? Kindly let me know, or else we are going to move forward. Any doubts, anyone? Any doubts? So how much part we have covered? So representation. So this is the last part that we have. Okay, how to represent Boolean expression. So copy this down very quickly. Very quickly you copy. Copied? Any doubts, anyone? Please tell me. Or else we are going to start the last topic for today. That is what? SOP and POS. Okay. Are we enjoying the session or what? Means you people are not at all responding. क्या हुआ? You people are not understanding. Tell me if there is some issue. Let me know that sir we are not understanding, or there is some issue with you, or we are not able to do this, that. Whatever is your problem, you can let me know. But don't sit quietly whenever I ask you that if you people are understanding or not. Okay. Copied. So now the last is what we have: representation of Boolean expression. Okay. So Boolean expression, I can represent it in two ways. Okay. Those two ways are what? Sum of product. Also in short form it is written as SOP, or I can even write it as product of sum, or POS. Okay. So one by one, let us see what is this SOP and what is this POS. So first, let me tell you what is product terms. What are these product terms? Or sum terms. Okay, product terms or sum terms. So product term, it can be something like, if it is 3 variable, it can be like this, or it can be like this, or it can be, if it is a 3 variable, I am talking about if functions are a, b, c. Okay, if functions are a, b, c, it consists of 3 variable. So product terms can be like this, or it can be simply b complement c, or it can be even a simple, a single term. So these are what? These are your product terms. Now again, if I have sum terms, so here also I have 3 variables a, b and c. So the sum terms can be like f1 a plus b plus c, f2 it can be a plus b complement plus c, or f3 it can be b complement plus c, or f4 it can be a. Okay, tell me if this is clear or not. This is a product term. These are known as product terms. These are known as sum terms. Okay, sum terms and product terms. Now I am going to show you what is sum of product and product of sum. Okay. So first term is what? Sum of products, also known as SOP. Okay. So what does the name suggest? Sum of products means what? You have different product terms. Okay, you have different product terms, you are just summing them. Okay, summing them. Like one of the example can be f is equal to ab plus, I could have taken from here, or it's okay. Means here also f is what? Here is f is function of a, b, c. So sum of product terms, it can be like this: a, b, c plus, means we are just simply summing the individual product terms. Okay, it can be like this. So this is what? This is sum of product. Please tell me up to this point, have you understood? Now this is very important. Till the end, this is going to stay with you. SOP and POS. If any doubt, please let me know. Okay. Any doubts, anyone? Okay, fine. Now this SOP, this is SOP. This is not a standard SOP. Now, what is the standard SOP? And why is this not standard SOP? So, a standard SOP basically has all the product terms, all the three variables. Okay, like over here we have three variables. So, in standard SOP, all this product term should have all the three variables. Like, suppose if I want to convert this SOP to a standard SOP, so I can write it like this. Look very carefully. I want all the product terms to have basically A, B, C. Okay. So this product term has all the three A, B, C, you can see. Even this one has all the three terms A, B, C, means here you have a complemented form, it's okay. But we have all the three variables A, B, C. But the second term, there is missing A variable over here. So what I can do, simply in SOP to make it standard, I am going to multiply it with A plus A complement. So if I expand this, this will be what? A, B, C plus A, B complement C plus A, B complement C plus A complement, B complement, C complement. So this function, it is what? It is your any doubts? Any doubts? Anyone want to ask anything? Anyone want to ask anything? Now the most important thing, okay? In sum of product representation, basically your complemented variable it corresponds to 0 and your normal variable or uncomplemented variable, it corresponds to what? It corresponds to 1. Okay. So basically, if I want to show, so look very carefully. Here we have three variables A, B, C. So the corresponding SOP for this, it will be what? So look very carefully. So let me make a table. So this is decimal corresponding to 0, 1, 2, 3, 4, 5, 6, 7. Okay. So the corresponding SOP term for this configuration means this representation of ABC, it will be what? A complement, B complement, C complement. Over here, this will be what? If I want to represent this, so this will be A complement, B complement, C. This will be what? A complement, B, C complement. This will be A complement, B, C. This will be A, B complement, C complement. This will be A, B complement, C. This will be A, B, C complement, and the last term will be A, B, C. Tell me, up to this point, is this clear? Is this clear? I am talking about if these are three variable, if I have a three variable expression. Now, all these terms like this one, individual terms, they are basically known as what? They are basically known as min terms. They are known as what? They are known as min terms. and the minterms, they have corresponding minterm numbers. Okay, minterm numbers. So this corresponds to, look here, decimal 0. So I am going to write it M0 in small m. This is small m. Over here I am going to write M1. This will be M2. This will be M3. This will be M4, M5, M6, M7. So if I want to represent, suppose I want to represent this function. Okay, if I want to represent this function using SOP, so how am I going to write? I am going to write f is equal to sigma. Why sigma? This is sigma, capital sigma, because this is sum of product. So summation of product. So you can write it like small m, then you can write open bracket. So look over here, this standard SOP, ABC corresponds to 7. This corresponds to 1, 5. So have I done some mistake? Okay, so this will be also 5, and this will be what? This will be 1. So we never actually repeat the terms. Okay, we never repeat the terms over here. So how am I going to write? I am going to write it in your ascending order. So that will be 1, 5, 7. So this whole expression I have written it in 1, 5, 7. Why? Because I can condense this two term in a single term. Okay, I can simply condense it in a single term and write. So this whole expression in minterm, I can write it like this, or even I can write it like M1 plus M5 plus M7. So this is what? This is your sum of product representation. Tell me if this is clear or not. Is this clear? Is this clear? So, okay. So I have a function represent it in terms of minterm number. Represent it, or you one way of asking is write this in standard SOP form. Write this in standard SOP form. Write very quickly. So write this in standard SOP. So look, so this is basically a 3 variable. Okay, I should have written it like this. I'm very sorry. Okay, 3 variable. So if I want to convert it into standard SOP, here C is missing, here B is missing, so this is what? A B complement C plus A B bar C bar plus A B C plus A B complement C plus A bar B bar C bar. So this corresponds to what? in your SOP format, this corresponds to 0, 0, 0. This corresponds to what? 1, 0, 1. This corresponds to 1, 1, 1. This corresponds to 1, 0, 0. And this corresponds to what? 1, 0, 1. So this is 5. This is 4. This is 7. This is 5. This is 0. So either I can write f as summation min terms of in ascending order 0, then 4, then 5, then 7. Either I can write it like this, or I can write it like m0 plus m4 plus m5 plus m7. How many of you got this one? Tell me. Or even you could have written it like this: 0, 0, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1. Any way you want, you can write it. Okay, any way you want. Any doubts, anyone? So the last is what? Today's last topic, it is your sum of product. Okay. Sorry, product of sum. Product of sum, or also defined as P, is also written in short form as POS. So in product of sum, basically what we have sum terms, and those sum terms are actually in product form. Like if I want to write one POS form, so it can be like, if it is a 3 variable POS, so it can be like this. Okay, so this is what here you can see. We have individual sum terms, sum of product. Okay, sum of product. Sorry, product. What I am telling. Sorry, product of sum. So product, you can see product of these sum terms are known as what? It is known as POS. Previously, what we had sum of product. So sum, you can see, of product. Okay, sum of product. Now we have what? Product of sum. Okay, so understand the difference. Now if this is product of sum, is the standard POS? See, a standard POS, these are basically max terms. Okay, these are max terms. All the terms of product terms should have corresponding variables A, B, C present, or all the max terms should have all the variables present. So this is what? This is not standard POS. Now if I want to convert it in standard POS, what I can do? I can write it like this. Okay, so here you can see this is what I can use. Basically this is A dot A complement. So simply what I can do, sorry, so what have I written over here? So this is B plus C. Okay, this is B plus C. Now look at this term first. So I can write it like B plus C as X. Okay, so this is what? X plus A complement. So I can write it like X plus A into X plus A bar. I can write it like this. Over here also I can write it like this. So simply first see very carefully how I am writing this. So this will be A plus C complement plus B complement, A plus C complement plus B. This term if I expand, so I can write it like A plus B plus C, and next will be what? A complement plus B plus C, and over here this is in complete form. So let me erase this. This will be what? A plus B plus C, over here A complement. Okay, now again I need to expand this. Okay, so this will be what? A plus B complement plus C, A plus B complement plus C complement. This needs to be expanded, so this will be A plus B plus C, A plus B plus C complement. Again these three terms are present. Okay, so this is, now you can see all the terms have A, B, C present. Okay, so this is what? This is standard POS. Okay, this is standard POS. Any doubts? Tell me. Any doubt? Fine. If you people don't have any doubt, so over here in product of sum, complemented term, complemented variable is represented by 1 and normal variables are represented by 0. Okay, so complemented variables are represented by 1 and normal variables are represented by 0. Okay, so now suppose if I have a 3 variable function. Okay, 3 variable functions. So this corresponds to decimal 0, this corresponds to 1, this corresponds to 2, this corresponds to 3, this corresponds to 4, this corresponds to 5, this corresponds to this, and this corresponds to 7. So in POS form, basically 0, 0, 0, it corresponds to some terms. Okay, some term, also known as your what? Some terms are known as your, there is no space, it is known as your max terms. Previously your product terms were known as min terms, some terms are known as max terms. So corresponding to this, this corresponds to basically what? A plus B plus C, if it is written in POS form. This will correspond to A plus B plus C complement. This will correspond to A plus B complement plus C. This will correspond to A plus B complement plus C complement. This corresponds to what? A complement plus B plus C. This will correspond to A complement plus B plus C. This will be A complement plus B complement plus C. And last will be A complement plus B complement plus C complement. So these are your max term. Now if I want to represent it in max term numbers, so max term numbers are represented in capital M. So this will be capital M0, capital M1, capital M2, capital M3, capital M4, capital M5, capital M6, capital M7. Okay, so these are your corresponding max term numbers. Now if I want to represent like this expression, okay, this expression, so this is what? Here remember, don't make this mistake that non-complemented corresponds to what? It corresponds to 0 and complement corresponds to 1. So this is 0, means let me write it below. So this will be 0, 1, 0, this will be 0, 1, 1, this will be 0, 0, 0, this will be 0, 0, 1, this will be again 0, 0, 0, this will be 1, 0, 0, and again this is 1 0 0. Okay, this is 1 0 0. Now this corresponds to 3, this corresponds to 2, this corresponds to 3, this corresponds to 0, this corresponds to 1, this 0, this corresponds to what? This corresponds to your 4, and even this corresponds to 4. So now if I want to write it in your SOP form, so f is equal to, this time pi. Pi represents multiplication, capital M, bracket open, in ascending order write the maximum number, so that is what? 0. So this 0 has been taken care, this is 1. So 1 is taken care of, then 4, sorry, we have 2, 3, and then we have 4. Okay, so this is what? This is your maximum representation for this one. Okay, or you can even represent it like capital M0 plus capital M1 plus capital M2 plus capital M3 plus capital M4. Okay, you can represent it like this also. Tell me, any doubt in this? Any doubt? Any doubts in this? Or else we will be ending the session over here. In the next class, I am going to tell you few more things. I guess today it's okay. Up to this point we study. Any doubts, anyone? Any doubts? You guys can speak up now. Okay, it's not like I am going to scold you. Any doubts up to this point? So okay, in our next class we are going to see more things about SOP and POS, and we are going to start K-map. So in that we are going to solve a lot of questions. Okay, so we are going to see a lot of questions in that. Okay, so okay, then I will be ending today's session. If you have any doubts, please